Today I'm going to be going over a Algebra 1 STAAR checklist regarding multiplying polynomials. And a checklist is just a list of example problems where you ask yourself, do I know how to do this? Once we cover one, you should be able to try the next two on your own to verify whether or not you're getting the correct answers with that process. So looking at number 1, it's asking which expression is equivalent to this polynomial. And then they give you a bunch of these answer choices. So when looking at this problem, we have to look at this problem and see we have two sets of parentheses that are stuck together. So they want us to multiply these two binomials. Well, to multiply binomials, we learned about something called the box method. And that is where we take the terms in this binomial and we write it up top. And we write the terms in this binomial and we give it to the side. Now, we're going to fill in each corner by multiplying the outside terms. 2 times 3 is 6. A to the power of 1 times a to the power of 1 is a to the power of 2. In this corner, we have 5 times 3a. 5 times 3 is 15, and the a is now stuck with him. In this corner, we have 2a times negative 2. That's negative 4a. And in the final box, we have 5 times negative 2, which is negative 10. At this point, we're ready to start taking our terms out of the box to get our final answer. So our answer is 6a squared. And then I noticed that these diagonals actually have the same variable, the same base, so we're going to add those up. So negative 4 plus 15 is positive 11a. And then we'll take out our last term, negative 10. This is our answer, which we can find right here. Option C. Number 2, which expression is equivalent to this? Again, we have two sets of parentheses that are stuck together, so they want us to do quite a bit of multiplying here. So I make my box. I have n minus 4. I have 2n plus 7. Here we have 2n times 1n, which is 2n to the power of 2. Here we have 2n times negative 4, which is negative 8n. Here we have 7 times 1n, which is 7n. And lastly, we have 7 times negative 4, which is negative 28. Be super careful when multiplying with the negative numbers. Just double check yourself to make sure you're on the right track. Now we're going to take out our terms for our answer. Here we have 2n squared. And then checking those diagonals, they have the same base, so we are going to add them up. 7 plus negative 8 is negative 1n. And the last term is negative 28. That is our answer, which we see right over here in option D. Now we have number 3. This one is a little bit different because this has 3 terms and this only has 2. To do something like this, we're just going to make ourselves a larger box. I'm going to do this. I'm going to make a box that's a little bit longer because we just need space for that extra term. So I'm going to make it so that this binomial fits on the side. So negative 4h, positive 3. And then I'm going to make it so that these 3 terms fit on the top. So h squared plus 9h minus 1. This is the same process. We just have to be careful of those exponent rules. So add our 1's. Here we have negative 4 times 1, which is negative 4. And we add those exponents. He's got a 1, he's got a 2. 1 plus 2 is 3. At this point, we can actually start canceling things. So I know that first term will be a negative 4h to the power of 3. So it's either A or C. Now here I have 9 times negative 4. That is a negative 36. adding my little exponents. 1 plus 1 has a 2. And lastly, we have negative 1 times negative 4h, which is a positive 4h. Next, I have this bottom box. We'll multiply 1h squared times 3. That's just 3h squared. Now here I have 9 times 3, which is 27. And that had an h, so will our product. Lastly, we have negative 1 times positive 3, which is negative 3. So now we're going to take our answer out. This term always comes out first because it has the largest exponent, and we want to write our answers in standard form. But now we're just going to check our diagonals. These diagonals have h power of 2, h power of 2, so I can add those. 3 plus negative 36 is negative 33h squared. And then I'll go ahead and check these diagonals. That has a h1, that has a h1, so I can add those. 27 plus 4 is positive 31h. And lastly, our negative 3. So this is our answer. And just checking it, I see that option A has all of the proper terms. So that is a more advanced version of the box method. Number 4 says, the diagram shows the floor plan of a storage facility. All dimensions are given in feet. Which expression represents the area of the storage facility in square feet? So we have to know the formula for the area of a rectangle. Well, area is equal to the length times the width. So let's just say that this is our length and this is our width. So our problem becomes, what is length, 5x plus 4, times width, 4x minus 4. So here we have another version of the box method. We're going to make our box. Here we have 5x plus 4, 4x minus 4, and we start filling it in. 5x times 4x is 20x squared. 4 times 4x is 16x. 5x times negative 4 is negative 20x. And 4 times negative 4 is negative 16. I know my answer will have 20x squared in the front. And then I just have to figure out, what do I get when I add the diagonal terms? Negative 20 plus 16 is a negative 4x. And then we'll bring out our negative 16. So this is our answer, which we can see is right here, option B. Number 5 is similar, but we have to know a different formula because they're asking which of the following represents the area of the triangle. Area of the triangle. Now the formula is 1/2 the base times the height. So looking here, this is your base, this is your height. So we are going to be doing 1/2 the base, 2x plus 2, and the height, x minus 2. So there's a couple ways to do this, but at this point, I'm actually going to show you a calculator strategy that we have learned before. We already set up our problem, and what we are going to do is ask ourselves, what variable did they use in this problem? Well, they used x, so we are going to make x assigned to a random number. I usually start with 4. And we are going to program the calculator to replace x anytime it sees it with the number 4. To do that, we use that funny little equal sign, control, and then that button right there. So now that I programmed the calculator, we're going to type in the problem that we got. So 1/2 parentheses, 2x plus 2, x minus 2, and I got 10. So now I'm going to type in each answer choice until I also get 10. Well, option A gives me 12, so that's not it. Option B is 2x squared minus 4. That gave me 28, that's not it. Option C, x squared minus x minus 2. That gave me 10, so that's probably our answer, but then we want to check this one. 2x squared minus 2x minus 4. That gave me 20, so that's not it. So here our answer is C. Now, if we wanted to do this by hand, the way I would do it is figure out what this is using the box method, and then just multiply each term by 1/2. So let's first figure out what does that product come out to. So I have 2x plus 2. Now I have x minus 2. 2x times 1x is 2x squared. 2 times 1x is 2x. 2x times negative 2 is negative 4x. And 2 times negative 2 is negative 4. So I'm going to rewrite this. I have 1/2, and now let's just write what we get from our box, which is 2x squared. And then adding these together, negative 4x plus 2x is negative 2x. And then I bring out that negative 4. So we can see this option looks very similar to what we have, but we have to multiply each term by 1/2. So 1/2 times 2, let me just show you here so you can see it. 1/2 times 2, well, that's just 1. So I'm going to bring out 1x squared. Next, I have 1/2 times negative 2. So 1/2 times negative 2. Well, that's negative 1. So minus 1x. And then I have 1/2 times negative 4. So 1/2 times negative 4. Well, that's negative 2. So this is our final answer, which we can see aligned with option C. So those are some STAAR level examples of multiplying polynomials from kind of the simpler versions down into the advanced areas. So you have to remember your formulas and you have to remember your rules.